Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's an honor today to welcome Joichi Ito to speak with us today and tell us what's going on at the Media Lab. I heard this morning that Joichi means large harvests from peasants, and Ichi is firstborn. So we're going to hear about that, a little bit about that today. Anyway, so Joey is not your everyday Media Lab director. If you look at his bio, you'll see it's quite an interesting choice to take on the reins of that organization, with incredible contributions in numerous startups, investments in some of the bread and butter of today's social computing, Twitter, Flickr, and so on. He was named by Businessweek as one of the 25 most influential people on the web in 2008. 2011, he was chosen by Nikkei Business as one of the 100 most influential people for the future of Japan, and by Foreign Policy magazine as one of the top 100 global thinkers. He sits on boards from MacArthur Foundation to Mozilla Foundation. So he has had tentacles everywhere, and he's now focusing his attention on the Media Lab. And we've become a member of that consortium this year, and we'll be speaking with him at lunch about ways we can engage even more intensively. So, Joey, why don't you come on up and be telling us today about innovation in open networks and the MIT Media Lab. Thanks.
Thanks,
Joey.
Morning, everyone. And thank you for joining the Media Lab. I remember, I think the conversation went something like, well, we already have access to everyone and everything at the Media Lab. Why would we join? And I think that's going to be our afternoon conversation. But this should be a prelude into that, because I'm going to talk a little bit about the philosophy. But I first want to start by doing a scientific experiment. And the scientific experiment, I'm going to ask you to hold up two hands when I say go. And it's going to answer a question, which is, how creative were you in art? So painting and drawing when you were in kindergarten, from a range of 0 to 10, 10 being I was Picasso, 0 as I didn't do it at all. Ready? Go. So I'd give like an average of 8, although there are a few people who are quite low. So there's the spread is there's some diversity, but I'd average around 8. So now the same question, except today. How would you rate yourself on that artistic scale? Go. Okay, so this is an interesting crew, because there's not that much of a diversity, but I think it's a little bit lower. It was probably about like a 5 or a 4. So a lot of groups I find it go from 9 to 0. But I think you can kind of understand where I'm going here with this, which is that in a world where we cherish innovation, and we think that creativity is an important thing, if you think that your confidence in art is at least one measure of creativity, something happens. And this is kind of a page out of Ken Robinson's books. I'm not the first person to say this, but I think it's really important to think about the importance of creativity and innovation, the importance of innovation in society, and the fact that we, on many measures, don't believe we are as creative as we were when we were in kindergarten. So part of it you can say, oh, we get older, but I think we're different when our brains are different when we're older, but I don't think we're less. We'd have to be less creative. And so something that we do, whether it's yourself, your parents, your school, your society, something about society makes us less creative as we get older. And a lot of it has to do with what we need to do in a modern sort of industrial society, which is focus, produce, repeat, protect, all these other things that you need to do as an adult, right? And my assertion is that as the internet has come in and as the world has changed, the balance of the number of people that need to be creative in society versus need to be focused and repetitive and organized is changing. And I think the most important part of that is the internet. I think the internet the internet probably has impacted Microsoft more than just about any big thing since the beginning of personal computing, I would assert. And so to me, I want to start out by first talking about the relationship between the internet and where we're going. And so I'm 46, I guess, right now, and so I still remember the days before the internet and after the internet, whether it's my career or the people around me. So I split the world into these two halves. BI standing for before internet, where life was simple. Things like, it was kind of like Newtonian laws worked. When this thing hit that thing, this thing would happen, and things rolled at a certain speed, and life was predictable, and life was sane, and you could kind of be somewhat repetitive, even though there was some change going on. After internet, what we found is, first of all, those laws that we had, things became complex. Things became connected and fast, and so those Newtonian laws that we held so dear turned out to be local ordinances. But we have yet to figure out what those other laws are to predict the other things. So, the sort of, again, to just pick up book memes, it's like the black swans everywhere. Everything is obvious in retrospect, but very hard to predict. Our plans are often wrong. And so how do you think about surviving and thriving and working in a world that's unpredictable, where plans don't work, where things are complex? And again, not all of the world is here yet. I mean, you still have industries that are BI. But I think more and more of the world is AI, and Microsoft is dead center in the world of AI, I think. And so AI, I know Eric probably is saying, don't use the word AI. But anyway, you're flexible. Okay, good. And so we'll go through some of these. But some of the principles that I'm working on and the lab's working on, we don't have to read all these now, but I'm trying to come up with some principles of AI. What do you have to do to change in order to survive this shift? So I'm going to go back into my history for a second and talk a little bit about, this is how innovation used to happen in the network space and still happens in many of the spaces, which is, you have big companies and governments that send necktie-wearing experts to intergovernmental agencies where they sit around and they argue and they argue and they argue about every possible benefit, every possible risk, and they create these stacks of specifications that are like, meters high. And if you remember, many of you might, back in the 80s when we had X25, which was a packet switching protocol that was actually competing with the internet. And this was actually CCITT back then. And this was when I was getting into networking. And I remember these battles. And the thing about it was the specs that came out were so voluminous that only large companies would ever be able to render them into stuff. Because no one person, I tried to sit, I mean, maybe some people here can do it, but I tried to sit down and read like the specifications for X25 and to try to figure them out. And I, as a student, couldn't make heads or tails of it. So you have these large contractors that turn these huge binders of specifications into products and services that turn into fees. And this goes around and around. And I think for things that you can't change later, that have a high risk and a lot of infrastructure, like our phone system, our physical plant network, this may be okay. And there's a lot of books written about infrastructure investing and stuff like that. And so this works for certain things. But when we were working on the internet, and a lot of you here probably were working on it at the same time, and if you remember, like the Internet Engineering Task Force, and a lot of this happened on mailing lists. We were all, relatively speaking, equal. All of us, you have 12-year-olds jumping into conversations, and if they could write code, they had a voice. And it was really kind of a meritocracy. It was flat, it was disorganized, it was distributed. It wasn't centrally controlled for the most part. And this was really a battle, if you remember, between centralized, planned innovation and decentralized, somewhat anarchic, distributed innovation. And in a way, if you remember also, even today, the Internet Engineering Task Force, their specifications were really short, a couple pages long, and they had the very humble name, request for comment, compared to these government specs. And so this, in addition to being distributed, was very humble. Well, we all know that the internet won, right? And again, I think that what's important when we think about this triumph of the internet over X25 was that it's not just a technology triumph, it's a triumph of a philosophy. It's a triumph of a way of just doing innovation. And I think that that's the important thing about the internet. So to me, when I talk about AI, it's not about the internet being a particular kind of networking protocol, but it's a way of doing innovation, it's a way of thinking about things. It's really permissionless innovation, because all these people had permission to innovate. You couldn't open these phone switches without permission, without government authority. This is all about authority. This is all about hacking. So this, I think, is around 1991, something like that, 92. This is my toilet, but this is also the first commercial internet service provider in Japan. And this is an old Sun Spark 1, I think. This is a VT100 terminal where only half of the screen worked, so you couldn't actually see the whole error message. This is an old Cisco, I think it was AGS, and then we got the little hard disk here for the news. And this is, and the thing that's neat about this is a couple key things. So this cost nearly nothing to set up, and I could stick it in my toilet, where it's actually a bathtub, and the toilet's here. And then, because it's had the fan, because it was really noisy and hot. But for this low cost, this scrappy thing, we could create a point of presence. It would have cost any phone company to do a point of presence for anything, even X25, millions of dollars. And we were actually using, and this gets into technical stuff because you're a technical crew, but we were piggybacking on AT&T's frame relay, so we were just using the sort of space that they weren't using. So even the bandwidth was nearly free. So we could start rolling out the internet at almost no cost. And this was because the protocols were easy, they were open, and as long as you met the basic parameters of the specifications, you could join in the party and start an internet service provider. So one thing, so this obviously drove the cost of communications way, way down. Because if you remember from X25, it costs thousands of dollars to sit on a session because they charged per packet. You had to have bilateral agreements between all the companies. And if you set up a service, you actually had to get an NUA and do billing and all this other stuff. It was crazy. So this drove the cost of connections way, way down. And what that did was it lowered the cost of collaboration, which really sparked open source and free software. It also lowered the cost of distribution because you no longer really had to pay to provide a service on the internet. And these are key because when you connect them with Moore's law, which I won't have to explain to you guys, is you get the low cost of networks and the low cost of computing together creates a low cost of innovation, right? Because you no longer have to really pay for distribution if you have the right product. You don't have to pay for collaboration so much, and with computing costs down. So if you use Yahoo, Google, Facebook, any of these guys, their cost of actually putting the thing together, if the fact that the software is free, the fact that they could just connect to the internet while they were still students, this really lowered the cost of innovation. What does that mean when you lower the cost of innovation? Is it changes the model. So back when when Microsoft was founded or when pre-internet, usually, and not always, but usually you'd have to come up with a plan to raise the money to hire the engineers to build the thing. Because the traditional company, to get to a point where you actually had, and again, Microsoft's actually an anomaly probably. Most companies, you would have to raise $10, $20 million to actually get anywhere. So that because the cost of innovation was high, the plan came first, the money came next, and the engineers came last. When the cost of innovation goes to nearly zero, it flips, where you build the thing first. And in many cases, you don't really know what it is. Because I remember when I invested in Twitter, a lot of people who didn't invest, a lot of smart investors didn't invest. I remember the thing they said was, well, it's a feature, not a product. And it's a feature, not a company. But the thing is, in a network where everything is connected, features are pretty good companies, And so you build the thing first, then you get the money, and then you figure out what it is, right? It's kind of the opposite. And it's also engineer, then MBA, rather than MBA, then engineer, right? So this fundamentally changes the way everything is innovated just by changing the variable of the cost of innovation. And so what I would say is a couple of things. As we think about the internet, it became system over objects, because instead of trying to plan everything as one big thing, each element of the internet, David Weinberger's small pieces loosely joined, it's really about each humble little piece being a piece of this broader network and looking at it as a system instead of an object. Disobedience over compliance is really important as well, and we'll go into that more. But I think the fact that you hack the system and you don't ask for permission, I think, is an important element of that. Emergence over authority, because it's really this sort of rough consensus running code of the sort of evolution of protocols instead of whoever's in charge getting to decide everything. And then practice over theory, which is, again, rough consensus running code. Build first. Not necessarily build first, think later. Think a little bit, build, and then think some more. And sometimes you get it wrong. We got spam wrong. We didn't anticipate spam. We ran out of IP addresses. But everybody, for all the panic the spam caused, we were able to kind of fix it on the edges without messing with the network. And I think that it really is like an immune system that we have with the human body, is as we discover new kinds of pain and failure, we evolve through it. And that is really much a practice over theory version, I think. Because the theory is kind of like intelligent design, and I think a lot of companies try to do that with their products, and I think it's really hard. It changes the nature of risk as well, because this isn't a scientifically meaningful graph, but just think of this as an image. So this is the brain of a normal big company executive, right? Because you've got all these different possibilities of downside. Budget overrun, market failure, recalls, all kinds of stuff. And your upside is usually kind of linear. It's market share here, margin there. And some companies, Microsoft's one of them, I think, does make big bets, and they do have geometric growth in certain areas. But for the traditional big company, this is it's a small piece of what their mind is taking up. With venture, I think it's very different. So I do very early stage venture, but my average investment is about $100,000 a shot. So if I give Eric $100,000 and he fails, the most I'll ever lose is $100,000. Unless I make the stupid mistake of him calling me up and saying, I'm running out of money, help me out. And I say, okay, I'm going to help you. Or, give me my money back. Those all start to cost a lot of money, because if you think about the cost of your time sitting in the room right now for the period of an hour is probably more than $100,000. And so then you think about the energy that it takes to try to recover money that you've invested or to try to fix something that's broken is actually higher than just letting it go. And actually the time that it takes to read the business plan may exceed the investment. Right? Because I think that the minimum viable product for a software consumer internet product is about $30,000 right now, which is probably about 5 minutes of our time, right? And so I don't read business plans for low valued investments. And what you do is you go and you double down on these guys, because Twitter may become $1 billion, right? My investment, or like Facebook, any of these big investments, $100,000 will end up in the hundreds of millions or billions of dollars. So what you want to do is you want to take Eric, whose company is failing, say, you were really good. I mean, it wasn't your fault. It was just that AI wasn't popular at the time. And but you'd be perfect helping me with machine learning over here at Twitter. Why don't you join as a CTO? So if a good venture capitalist is going to be betting on lots of great people, most of them will be failures. They'll be moving the people around to keep them in the family, and then doubling down on the big ones. And then as long as there's a big one every couple of years, or every 5 years, or every 10 years, it still makes the fund extremely successful. Now, this is the same thing you can do in a company on the edges. It's hard to do in the middle. But then way out here, you've got things like Wikipedia. I mean, again, I'm going to pick on Eric. I mean, if Jimmy Wales had come up to you at MSR and said, I'm going to make the best encyclopedia in the world, and the trick is anyone can edit it. Isn't that cool?
I think he did come to us.
Did he? And you probably wouldn't have given him a seat, right? But I think the key here is that if the innovation cost is low enough, it doesn't hurt to try. And so like that ISP that I showed you, I went to a trading company in Japan and I said, can you invest $600,000 in this? And they set up a feasibility study corporation where they got all these experts together to talk about it for a year. Cost them $3 million to decide not to invest $600,000. So when the cost of thinking about doing something exceeds the cost of doing it, I think you have to question it. And then the other example, does everybody already know the 3M sandpaper Drew story? Okay, so this is actually an interesting. So 1925, and by the way, how much time do I have?
Go till noon.
Okay, I won't go till noon. So 3M was a sandpaper company in 1925, and what they were doing was they were sanding cars so that they could paint them. And what was popular at the time were these two-tone cars, and with two colors. So what they would do is they put these strong adhesive and butcher's paper, and they paint the cars, and then they'd rip the thing off. And one of the sales engineers kept seeing the paint get all screwed up, and they'd have to do it again. And he said, we're good at adhesives, and we know how to put adhesives on paper. I'm going to invent masking tape, and this is going to revolutionize paint. And so he goes and asks for permission to do this, and the CEO says, no way, we're a sandpaper company. Get back to work. And so and as the story goes, for 24 hours, he gives up. And then 24 hours later, he figures out, okay, well, managers cannot write anything more than a $100 check, or can't write a $100 check. So he starts writing $99 checks to vendors, gets all the equipment, starts to do research. And the CEO, and this is where there's two versions of the story, but one of my favorite version of the story is the CEO walks in the second time, looks at him, and walks away. And then this guy, Drew, invents masking tape, which revolutionizes 3M. And then that turns into Scotch tape. And then later, Post-it comes out from a similar thing, which was at the edge of the network. But the key here is that if it's not costing you that much, and it's an interesting peripheral opportunity, why not try it? And are you allowing that to happen inside your companies and stuff like that? That's one of the things that I think a lot about when I'm talking to the members of the Media Lab, because the Media Lab really is a place where everybody in the lab can make anything. And so the cost of trying things are so low that really what I'm all about is trying to find these things amidst 350, well, maybe it's a little bit more successful than this, but something like this. So the other thing as we get into here is, so again, being Japanese, I'll pick on the Japanese. I mean, I think like the Japanese like to invest in things that look like they have no risk. I remember like Rockefeller Center or Pebble Beach, and I remember talking to some Japanese government people who were investing the national funds into stock. And I said, what kind of stock are you buying? He says, oh, the ones with no risk. I said, well, that's like betting on the most popular horse in every horse race. You're going to lose money because the ones that look like they have no risk actually have the worst pricing. And the way that you make money is if I know Lily and I'm the only one that really knows her very well, or the field, and no one else wants to invest in Lily, I'm going to get at the best price. So I say, Lily, none of your friends want to invest. Hey, how about $1 a share, right? And so but she doesn't have a choice, so she's going to let me invest at $1 a share. So she does really well, let's say, and 99 times she won't, but she does really well, and she's in the New York Times, and everyone's like, Lily, sell us your stock. I'm selling, right? So what you do is, how you make money, generally speaking, in a world of risk, is you buy low and sell high, right? And I think this is kind of, you can apply this metaphor kind of generally. There's no such thing as no risk. And the things that look like they have the most risk are usually the most overpriced. And so what you want to do, whether it's high risk or medium risk, is you want to find stuff where your assessment of risk is going to be more accurate than the market. And therefore, you can pay less for it than the rest of the market can, so you can buy it. And then you sell when the information is in the price, when it's going to be overpriced because everybody's excited about it and it's a bubble, right? So the point is not to not take risk. It's to take risk in a thoughtful way with a portfolio, because you're going to be wrong a lot of the times. But avoiding risk is definitely not what you want to do. In the same way, I think in a world where you can't predict the future is not to resist failure, which is what strength is a lot about, like building lots of berms and doing all kinds of stuff. It's to be resilient, which is the ability to react to just about anything quickly, is more important than the ability to resist failure, because it's going to happen anyway. And I think the problem is strength, like firewalls, sometimes give you the sense of security. And we know that firewalls kind of diminish the sort of security anxiety of people who write applications, and I think it has caused problems. So I think the idea of everybody needs to be resilient is an important part. I mean, agility is also, and we talk a lot about agility. I think everybody knows that agility is important, but I want to drill down on this a little bit. But this is one of my favorite examples, 2005, YouTube. I'm male seeking everyone between 18 and 45 upload video. That was their first business model, dating site with video. And of course, it didn't do that well, and they pivoted quite quickly. They became, when I met them, we were Flickr for video. And I was like, okay, I should have invested, I didn't. And then they said, oh, wow, MySpace is growing like crazy. We're going to latch onto that, and we'll be the video embed for MySpace. So even though they weren't as good as Google Video, technically, I don't think, at the time, they grew because they were able to latch onto this distribution, and then Google eventually had to buy them. But the reason I bring this up is most companies, if they had spent 2 years working on this, had made a division, and they had patented it, they probably would have said, let's keep trying a little bit longer, right? And they wouldn't have pivoted. They would have missed the MySpace opportunity. But it was because it was a small team. They didn't have lots of code, and they went out running. And this is why the agile software development is really, really key, is to be able to take advantage of opportunities, but also dump code that doesn't work. And one of the biggest problems is, and I'm sure you have different versions of this inside of Microsoft. I mean, in Japan, I see it in a completely different scale. Is every patent, every line of code, every division that you have is a liability to agility, right? Because those are reasons why you don't want to dump stuff. And even when I have companies that have 1 week sprints, I'll see engineers crying when we say, hey, we're going to pivot. But I've been spent the whole week staying up all night. How can we pivot? We don't have enough data. Well, we ran it for a day. It's clear it's not working. Let's pivot. And what you find is even with a week, you have crying engineers. Think about what it happens if it's 2 years or even longer. I would commend Microsoft, because Microsoft's pretty good at pivoting, considering how much you invest in things sometimes. But I think that it's really important to think about the balance of liabilities and assets in the context of agility. this is where, I don't know if I don't know if I have the slide in here, but pull over push. So John Seeley Brown has this great book called The Power of Pull, which is really about pulling assets and resources as you need them rather than stocking them and centrally planning them, and to pull them from the edges of your network. And the obvious version of this is kind of like, well, learning a computer programming language in school because you might use it 10 years from now is probably not a good idea. But even more common is companies really do like to try to get stuff together before they go. And Reid Hoffman, sort of as a contrast to ready, aim, fire, he says aim, fire, aim, fire, aim, fire. I mean, I think the ready part is a lot of people spend a lot of energy on. This is sort of my compass over maps, is when the cost of deciding to spend $600,000 costs $3 million and it's also wrong, that's an extremely expensive, inaccurate map, which is what most people have in their plans today. And it's also what strategy is. I mean, I heard that Sheryl Sandberg said that at Facebook we don't do strategy because by the time we have one, the world has changed. And I think it's because they're very focused on trying to retain agility in the face of growth. And I think that's a really interesting strategy. You do need a compass. I think you do need to have a vision. You do need to have some values, and you have to have a trajectory. But what you don't want is you don't want to have to top-down dictate everything that you do. And I don't think you guys do this. I think that, but it's kind of fractal. You can talk about this at multiple layers. The other key thing I think is serendipity. So serendipity and luck seem sort of like a statistics or probabilistic thing. But there's a lot of really interesting studies about serendipity. So one is, I think it was an English study, and I can send it to you if you want, or maybe I did send it to you, I think. But there's a study where they run a newspaper ad and say, if you're really lucky or if you're really unlucky, come to this test. And the test is, they get in and they give them a newspaper and say, how many photos are in this newspaper? Count and tell the examiner. And there's like 42 photos. So they're all counting. And then there's a big headline that says, if you see this headline, tell the examiner and you win $250. And then another headline, it says, there are 42 pictures in this newspaper. So all the lucky people obviously see the headlines. They say, hey, give me $250, and there are 42 pictures, and they're out. And all the unlucky people are sitting there counting all the pictures. They miss the headlines. And it's really interesting, that correlation. And it is really about whether you see the stuff around you. So in terms of peripheral vision, I think there's a study that if you put a dot on a screen, you show things in the periphery, you'll see it. But if you give somebody an incentive, like I'll give you $10 to watch the dot, that disappears. And I think that the focus that we so cherish in companies about execution and things like that, it does limit your peripheral vision. And if you plan everything, you can't be lucky, right? And so I think that there's a really interesting balance between planning and focus versus serendipity and the opportunity and embracing opportunity around you. And it also ties in with pattern recognition. So how many people have done mushroom hunting before? A few, okay. So if you're good at it, it probably means that you know that when you do mushroom hunting, you don't sit and focus, because you're focused only on like 1% of your field of view. If you're focused, you kind of pull back and you focus on nothing. And then if you're good, and if you've done it enough, the mushrooms start to pop up through pattern recognition. I think small game hunters do that too. They fall back, and then they can see the little twitching animals and things like that. You see the difference, but when you're focused, you can't, because you're just cognitively filling in all this other stuff with things that you assume will be there. And this is also really important, is when you're trying to look for peripheral vision and the opportunities around you and where you want to pivot, you can't really be focused by definition, because you're only looking for what you're looking for. And this is directed research is this way, because you're saying, I'm going to build this thing, so give me this money, I'm going to focus now. In a funny way, I won't overstate this because it's not always true, but peer review sometimes like that too. So I've got to explain this in the words that they understand. How do I explain this? How do I make this a thing? I've got to be focused about it. It does tend to limit your ability to discover things while you're on that path, right? And so to me, pattern recognition and peripheral vision are essential for discovery, but we have a lot of systems that sort of emphasize the opposite. I'm going to give a quick example of what I would call the power of pull. So Safecast is a nonprofit that I helped start in Japan after the earthquake there. And I was actually interviewing for my job at the Media Lab when that happened. And so I was kind of panicked because my wife and our family were in Japan. And I didn't know anything about radiation, Geiger counters, or anything like that. So I called a bunch of people and went around on the net. And so one of the guys I found was Ray Ozzie, by the way. So he's like, I don't really have that much to do, but I'd love to work on the data stuff. So he jumped in. We found this guy who worked, Dan, who did the 3 Mile Island Geiger counter measurements after the event. Jun Murai from KO had a sensor network. Bunny from, he actually hacked the Xbox. It's why Microsoft people might know him. But he was an open hardware guy. He ran a bunch of hackerspace networks. He did the Tokyo, the LA hackerspace. Sean, he was part of the Tokyo hackerspace, and she was at IDEO. He was a bank CIO, but he also understood analog devices. We had a group of people working on the web stuff, and Kickstarter, and some people who kicked in a little bit of money. And we were able to, within about a week, pull together a pretty cool crew of people, and we were able to really start to understand a lot of the issues as well as the health around it, and visualize it. But we realized very quickly as we started to try to build Geiger counters and deploy them, because we were trying to kickstart Geiger counters in Japan, is that the sensors were in limited supply, and the kind of large pancake sensors we had, we just didn't have enough. So we needed to go mobile in order to collect enough data. So we invented the bento box Geigy, or the B-Geigy, which we put on cars and we drove around. And so we had local volunteers. And this was right after the disaster. Literally, these government people in hazmat suits were showing up, measuring soil, and measuring data, and they'd walk away and not tell the people anything. And these people were freaking out. And traditionally, these kind of rural Japanese villages are a little bit xenophobic. They really don't interact with foreigners that much. But when these guys came in, with Geiger counters and explained that the kids that were sitting, that the cesium was stuck to the roof, and so the measurements were higher on the top floor than on the bottom floor, so maybe they should move the kids out of the attic to the floor, or this area was contaminated. And what was really neat about this was, like, after they kind of went and started working with these people, the local Fukushima people set up a nonprofit, and they said, okay, well, you guys, the government didn't help us, but you sort of, even though you're foreigners, citizen scientists came in and really helped us figure this out. We're going to create a nonprofit. We've learned how to do this. If something happens anywhere else in the world, we're going to go there and help like you did and say, we're from Fukushima, we're here to help. And to me, what was a really interesting thing about this is the government was completely failing at this time. No data, actually wrong data. And all of us had figured it out, and we had connected internationally with really nothing. Right? We started from a position where we knew nothing, and then a week or a month later, we knew more than the government did, at least in terms of figuring out the data and deploying in these areas. And this is one of our students at the Media Lab created, but we now have over 3.5 million data points that are available under a Creative Commons CC0 public domain dedication. And a lot of interesting things. I mean, we found out very early, even before the government had announced, that people were being evacuated from low radiation zones to higher radiation zones, and it was blotchy. A couple minutes away, you would get 10,000 times difference in radiation measurements and things like that. So you couldn't just fly over with a helicopter. You had to go in very granular. And anyway, so this project has become very successful. We're now starting to do air quality monitoring in LA, and it's expanded as a huge citizen science project. The key point here, and I'll finish this and I'll go. And by the way, Geiger counters don't get innovated on very often, and except during these sorts of things. So Bunny designed this Geiger counter, which is sort of very state of the art, and they're being manufactured in China now. They're really great Geiger counters if you want one. But we also made it available under open hardware license. But just to back up, I think the point that I was trying to make about the power of pull is, I think it wasn't actually a liability that we knew nothing. It was actually an asset that we knew nothing, because then we could pull in all of the experts that we needed that were available at the time, and every single project that looked similar to us, we just merged. And I think it helped that it was a crisis, so people were more happy to be mission-oriented rather than kind of selfish. But the fact is that compared to what the government was able to do, we completely beat them. And now we're on the front page of the Fukushima prefecture website. So they've a year and a half finally acknowledged us and brought us in. But I think my point is that all the planning in the world didn't help the government very much, and actually I think hampered it. And today, with all the resources available on the net, you can usually find the people that you need very quickly. I'm going to pivot a little bit here because I think open hardware is really important. So I was talking earlier about open source software and the internet lowering the cost of innovation for consumer internet and software. I think it's happening in hardware. Open hardware is going to be a key component of that, because just like open software made it so that at Google, all they had to do is really figure out the difference and write a small piece of software. They didn't have to rewrite databases and rewrite the operating system and rewrite Apache. They just used them. I think open hardware is going to help kids focus, like the Geiger counter that we made, we really didn't have to do that much except some of the analog circuitry and the UI, UX. Everything else we're using Arduinos and all these other things that were off the shelf that were open. And this is in our Center for Bits and Atoms, we have, this is a multi-purpose, multi-fab machine, so it does cutting, milling, and 3D printing. This is one of our groups of students that have spun out, and they're going to make a sub $5,000 very hard plastic, high-quality laser-driven 3D printer. But the cost of 3D printing is going down. You have companies like PCH International and others that are doing the supply chain side and the manufacturing side, so that the risk and the cost of manufacturing and the agility of manufacturing is going down. And so to kind of put it in your space, you see HP with the 4 or 5 year roadmaps getting out of hardware because they're not agile enough. Then you see you guys making tablets. You see, Apple really focusing on trying to stay agile. You see, Google buying Motorola. You see rumors about Facebook getting into mobile phones. I don't know if that's true or not, but it makes sense that the companies that have the agility, now that hardware is cheaper and more agile, are beating the hardware companies who don't have. It's harder to become agile, I think, than the other way around, and hardware is becoming speedy. My guess, though, is that just as the innovation got taken from huge companies to medium-sized companies to the edges, I think that hardware, starting this year maybe, and this is, Kickstarter is going through its growing pains around this, and sorry, I'm an investor in Kickstarter too, so it's a disclaimer, but I think they'll get over it, and that kind of sort of grassroots hardware movement, I think, is going to have a lot more traction. Yeah.
Question about that, because I've noticed that trend too, but I've always wondered about like the Arduino kind of small hackerspace kinds of things. It seems like when people are doing things at small scale, that's really true. It's very easy to build up something small and stuff. But then the more they get into large scale production, the more calcified their infrastructure becomes. And do you think that part is changing at all? Is it possible to get into big scale and still be?
Yeah, I think that companies like PCH are going to make the difference. And so, without disclosing too much, I think there's a couple different pieces. So there are industrial scale supply chain manufacturers who are willing to do startup things now. So all my hardware startups are now working directly with the manufacturers, and they are taking on a lot of the inventory risk. They're actually betting on these startups because they realize there's more upside now, and that they have the capability to play. And so for some of the hardware startups that I'm working on, so for instance, a couple of things have happened. So the inventory cycle now has gone from about 4 a year for some of these companies to about 53. So the inventory risk is really low. And actually right now for most of these companies that I'm working on, you pay to China and they ship directly from China. So you don't hold any inventory in America. So they're actually using the same database and everything that they use for Apple and everybody else. And so you're actually getting the same quality. And it's extremely flexible, right? So scaling up is easy. There are different ways to do it. You can start local, like with a Spark Fund, blah, 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 and then move on. Or you can bring these guys in very early. But like PCH has an accelerator program now. They're actively pulling startups in. So I've seen the cost, like the business plan cost of startups going from the sort of $10 million range to like the $1 million range to do these hardware startups, just because they don't, the inventory risk and a lot of the tooling and all of that. Again, it's a little bit tricky because they're also just new to this. So they want to make sure they pick the winners. They're not doing it for everybody. But for the ones that look successful, I think that profile's changing. So I think actually this is the year. I think it's an important year. And I think as Microsoft has sort of figured out how to interact with startup companies and venture, they're going to want to do this in the hardware space. One really interesting note would be to note that a lot of the telephone companies have started, the mobile carrier companies handset companies have started really looking at Shenzhen and Shenzhai for their R&D labs because they kind of ignore IP and in some of the areas there. And what's interesting about that, though, is that sort of impunity actually unleashes creativity. And so there are certain things like the double SIM phones that have been invented in the streets of Shenzhai that are now being re-imported back because there are certain kinds of innovation that happen in the absence of lawyers that are actually inspiring and interesting. And so that's
I see the hardware innovation happening like in other countries or places?
I think right now, for the short term, I think the factory floors of China are really where it's. I mean, the other thing that you see is like design school kids ending up now in China. A lot of my Media Lab students are going to China because they find out that if you're sitting on a factory floor in China talking to the people with a database of every single supply chain component and inventory, you can redesign the thing on the fly and have it fixed. I mean, like if you look at the recovery of the supply chains after the Japanese tsunami, those people that had people on the ground or had companies who had people on the ground who knew what were going on, they were able to design themselves out of the supply chain problem very quickly, whereas other people just waited. And I think it had a lot to do with how heavily you were in China. I think it may shift around a little bit, but and certain components may be in different places, but I think that right now that you really need to focus on China and Shenzhen specifically. But I think it's coming to biotech. So this is Joe Jacobson's stuff. He's the guy who did e-ink at the Media Lab. And so he's created a spin-out called Gen9. So I don't know how much you guys know about biotech, because I'm just repeating stuff that I don't really know. But so the metaphor here is, in the old days, you had to put transistors together by hand before the integrated circuit. And so the limit of the complexity of a device and the cost of a device was dependent on the labor cost and the yield of this hand wiring process. So you had 1,000 transistors or whatever would be the maximum complexity you could get to, because you would introduce errors. And then the integrated circuit allowed Moore's law and complexity to go with electronic design and all that and so forth. So it was really the machine manufacturing and the assembly of transistors that really allowed complexity to occur. Right now with biology, what you have is this huge database of gene bank and all these. We have sequenced so many genes, yet we still go to the Amazon rainforest and squeeze trees to get the essential elements for our drugs, because we are not able yet to manufacture or understand biological devices to the extent where we could. There are some examples, like I think Dow created this cell that, or this basically a cell, but it's a biological device that creates polyester. Even though polyester doesn't occur naturally in nature, they were able to pull the genes together. But it costs a tremendous amount of money to design that. And then, but it's still, they dumped the old method, because the old method of petrol and all that was 75% efficient, and now they're over 90% efficient with the biological system. So biological devices are much more efficient. They're generally much more ecologically safe, but they're hard to make because the complexity of the devices and the testing of the devices is limited by the fact that you have thousands of people, again in China, putting these base pairs together by hand, and they introduce about 1 error per 100 base pairs. It's like the old transistor days. So now our lab, the spin out of from our lab, Gen9, prints genes on circuits, on CMOS, and it's about 10,000, 1 error per 10,000 base pairs. We'll probably up by another order of magnitude very soon. And they print lots of it cheaply, very fast. So we'll have half of the world's gene printing capacity in Kendall Square within a year. And so what that does is, it's a lot like the integrated circuit. It suddenly allows us to take this huge gene bank of all these gene expressions we know, print them, test them. And now with microfluidics, you can actually test all these. If you go over to VIS or something, you'll see a heart on a chip, a liver on a chip, lungs on a chip. And so the testing cost is also going down. I think the regulatory cost of innovation is actually higher now than the other part. But now, as you can imagine, the explosion of complexity with the ability to print really complex gene sequences, the ability to test them without having to go through the same level of cost in testing, may create an explosion of innovation around genes. And just so you know, this affects electronics in a lot of ways. And we have, we can create memory, we can create sensors. There's all different kinds of biological devices that will replace things that are right now traditionally made either mechanically or out of petrol or kind of through brute force. So I think that what I'm saying is that the idea of the low cost of innovation, pushing innovation to the edges outside of this centrally controlled, authoritative research lab, is a trend that started with software and consumer internet services, but is pushing its way into hardware and then eventually into biotech. And so then I'm going to talk about the Media Lab. So the Media Lab is an academic institution, but we definitely are a disobedience over compliance sort of place. So when I say disobedience, I don't mean to be disrespectful, but it means you don't win a Nobel Prize by doing what you're told. And even if I expected it, they wouldn't do what I told them to, but I don't expect it. And emergence over authority. Learning over education is very important. I think that, to me, education is what somebody does to me, and learning is what I do to myself. And I think a lot of, well, all of the focus of the Media Lab is really around learning through construction, learning through passion, learning through doing, and not learning through instruction, and practice over theory. So, and this is actually pretty critical, because when you have a massively interdisciplinary place, you can't have an opera singer and a sociologist and a mechanical engineer write an academic paper together very easily. But you can build a robot together, and then the robot you can look at, and it's pretty rigorous. It either works or it doesn't, you know. And so building stuff is actually a really good way of testing theory in the absence of theory. Our degree is called Media Arts and Science. And a key thing here, by the way, is that the Media Lab is the only lab in all of MIT where we also have the academic program. Everywhere else they're separated. So you have like the school, you know, you have a EECS, and then you have CSAIL, computer science. And so the labs have the money and the research, and the academic programs have the degrees and the students. And somehow that's like church and state. So we were able to kind of break that rule. And what that allows us to do is say, for instance, let's get rid of classes, which we did. And so the students and the faculty have a 0 to minimal course load. And we focus on research. So we were able to change the academic program to focus on research. The one weird thing is this degree, a PhD in Media Arts and Science or a Master's in Media Arts and Science, doesn't really mean anything. You could have been an opera singer, or you could have worked on synthetic molecular biology. So it's also an interesting thing that it's a degree from MIT, but it's really, really difficult to say what actually you've learned. But all of our students have a really high, what is it? Their employment ratio is very high, which is also kind of an interesting thing, because somebody from an assessment agency the other day came in and said, I just met like 5 students, I want to hire them right away. And I said, well, you know, there's no requirement to get into Media Lab except for an interview with a professor. And a degree doesn't mean anything. And so how can you really believe in assessments if you want to hire all of these kids who have never been assessed? You know? But, so we were founded in '85 by Nicholas Negroponte and Jerome Wiesner, who was the president of MIT at the time. And back then, if you remember, it was before the internet. It was before the personal computer. It was kind of like it was like near your birthday, right? When is Microsoft's birthday?
75.
75. Okay. So it was a little after your birthday, but when you were still small, right? Huh?
Before you went public.
Before you went public. Okay. And so what's important back then is, you know, Nicholas was writing the book Being Digital. It was really about man-machine interface, about empowering the individual. It was about consumer electronics, inventing the personal computer. And so that was the focus back then. I think I'll talk a little bit about it, but the world's obviously changed a little bit. We have currently 26 faculty who are our principal investigators. So we have each faculty has a group, and each student applies to a group, not the institute. So we don't admit students as a group. The faculty admit the students, and each student has a main faculty. And we have 140 graduate students, master's and PhD, and then about 300 research projects. We have 80 member companies who are like our sponsors, and about a $39 million operating budget. I won't go through all these groups, but they're extremely diverse. The key thing is no 2 professors are in the same field. So the whole point is diversity. And so we get criticized for that a little bit sometimes because it's kind of shallow. Each of these people are fairly deep in their own way, and they're connected to their cohort. But the key is that they can all talk to and work with each other. But we really do have everything from robots to networks to biomechatronics and robotic limbs to Sepp, who was doing social computing. Let's see, I don't know what other random. This is like high-low tech, which is sort of the maker stuff. Anyway, and we have opera of the future, and you get the idea. And molecular machines. So it's and optics. It's very diverse. We just did a faculty search, and we're doing more faculty searches. I'd love for ideas. Maybe some of you should apply. But sorry. But the requirement, and I'm really happy that MIT let us do this, the requirement for our faculty is they have to be anti-disciplinary. And again, this doesn't mean that they need to be rude. It means that if you can do whatever you want to do in a particular discipline, you should go do it in that discipline. If you could do whatever you want to do in some other institution, you should do it at that institution. You should only come to the Media Lab if we're the only place that you can do what you want to do. And that's true with the students as well. And so most of our faculty are only applying for jobs with us. And the reason we have, I think, around a 95% yield on students that we admit is because most of the students are also only applying to the Media Lab. And so they really are like a collection of really interesting misfits. They usually don't fit in a discipline for a variety of reasons. Maybe it's because it's new, maybe no one can understand what they're doing, or because it spans too many different disciplines. But for whatever reason, if you don't fit in anywhere else, that's how you fit in at the Media Lab. And how, this is one of the few moments of consensus that we had at the faculty meetings, which is, this is how we measure ourselves, on uniqueness, impact, and magic. Magic is important because magic is kind of, it's about the narrative, right? So we don't want to do biology 2.0, but bionics and human augmentation is kind of interesting. So it's got to hold together also as a story. But this is kind of how we think about what we do. This is, part of it I think is a reflection of the fact that we spun out of the architecture machine group from architecture. We're still under the School of Architecture, but it's a very much an atelier model where we have these spaces these labs where people build things. So instead of sitting around too much, we have the offices and private rooms on the outside, and we pile people in the middle. And this is 3 different groups. This is the affective computing, biomechatronics, and medicine here. But the groups sit, and again, it's really about, if you have an idea, sit on a mailing list over coffee, just go and build the thing. I think it's really important. I mean, the Center for Bits and Atoms has a class called How to Build Almost Anything. And by the end of the class, you talk to any of the students, it's an extremely liberating class because they can pick up anything, just anything really, and they can tell you how you could build it. And it gives everybody, and they also have basic programming skills when they get in. There's a spread, but generally everybody can design, everybody can code, and by the end, everybody can build anything. And so suddenly, the whole cost of trying something is nearly zero, because if you get enough kids together, you can go to the basement and build a car, or a molecular device, or a cell. And so it's really interesting because then they're completely liberated. They don't sit around making PowerPoints. They sit around building the things, and then maybe making the PowerPoints later to try to explain what they built. I'm going to skip this slide. So one of the key things that's changed since the Media Lab was founded was that back then when you're making the next Walkman or the next consumer electronics device, is very product-oriented and UI, HCI-oriented. You still have elements of that, and it's still important, but I'm starting to push everybody towards thinking about more of the ecosystems of products because, to you it's obvious, but that's a big shift. And I've changed the name from sponsors to members because I want this to be a membership organization where the companies work together. Because if we're thinking about ecosystems, I want to see how Nokia's work and BT's work and Microsoft's work and GM's work works together in an initiative around the future of cities, rather than one company looking for a piece of IP to help them with a particular product for their Sharper Image catalog. So really the idea of the membership organization is to try to create a community that works with us, that inspires us for our research, but then we inspire them to work together. And so what I'm trying to do is to turn this into a network rather than a container, which is kind of what it is and was, into more of a platform. One of the examples I just want to give is I recently launched this thing called Innovators Guild, and this has pivoted a lot too. I originally thought, well, chief innovation officers of all of our companies seem like they're kind of a lonely bunch, and that they could learn a lot from doing rather than thinking. And so I wanted to create like a field trip where we take chief innovation officers and we build something on a field trip, and they get hands-on experience. So we decided we would do it in Detroit, and we did a few recon missions to Detroit, and we figured out very quickly that first of all, Detroit was like, well, we don't want any white boy do-gooders from a rich university coming in here and flying out, and we've had too many of you guys, and they were really kind of burned out with people coming in with solutions. And so what we realized is they really, well, first of all, they were resentful, and it was really hard to get in. And so we decided, well, this is actually a really interesting experiment in CoDesign, because the whole thing is they think they know their issues. How can we get more involved in it? So long story short, we pivoted away a little bit from this kind of drop in and do something and leave to trying to work with the community. And at the end, what we did is we spent a bunch of trips trying to identify those people in the community who are really, really neat, and who were doing interesting things, from urban farmers to a kid who was incarcerated for 19 years building communities, and all these different local people. we brought a bunch of Media Lab students. We had IDEO, who's one of our members, help guide the process of the design process, and a bunch of Media Lab students working on the hacking part. But we brought the people from the community, and what was really interesting was that we started out with a couple of design challenges that we'd sort of figured out after going a few times. But after, and this was like a 2.5, 3-day process, halfway through, most of these things were completely different. And these are some of the groups working on it. And these are some of our fellows. This is like Chris Bevins. He's a designer. He's from IDEO. They're building compost, doing soil testing and things like that. But what was neat about this process was that the kids in Detroit came back and said, wow, like there's one designer, local kid who's really, really talented, and he said, this design process thing is really amazing. It works, and it makes me feel, like I'm being productive. And here I'm sitting next to a kid from MIT, and I'm actually contributing because I understand the problem. I understand the constraints. The Media Lab kids were like, wow, we didn't realize, we thought we were going to come here to help, but we learned a ton because we realized that designing in the field for the people is completely different. And then these chief innovation officer types also obviously got a lot of it. But what was really, so there's a couple different things that why I'm mentioning this. So one is, I think CoDesign is a really, really important next step in this kind of innovation on the edges. Because if you think about kind of customer-centric design is a lot of what people talk about. So I'm telling my students, if you're talking to somebody from Microsoft, if you're talking to somebody from a bank, they're not your customer. Your customer is the people that they want to sell to. So if you really want to be valuable to Microsoft, if we really want to be valuable to you, for instance, and if we really understand Detroit, and we can co-design something in Detroit, that design is going to be much more interesting than something that's designed in Redmond for Detroit. Because that's what we figured. That was our learning. So we spent 4 trips going out there. The kids sat around thinking about all these different things with idea about what we could do to help Detroit. But when we got there, it was all wrong. And when we let them help us design what they wanted, it turned out to be exactly right, and these projects now have traction. And I think this idea of going where you're going and letting the customer design it, that actually also connects with super customization. It connects with DIY manufacturing. It connects with a bunch of really important trends, which is as the cost of doing things goes down to nearly zero, you really need to start involving the customers in the design process rather than just treating them as consumers. And again, I think that this process that we're developing here, I'm going to try to integrate more into the lab. We're going to be reaching out to different places. We already have, with Tata, we have this thing, MIT has this thing called frugal engineering, where we send students for 4 months to India so that they design within the constraints of India rather than plopping stuff in. Ethan's doing stuff in Africa. But we're really going to work on this co-design idea. And this is something that we'd love to work with you on as well. But anyway, so that's kind of a rough idea of the trend. And I think you see how this hopefully ties together, and hopefully it resonates with you at some level. Thank you.
Just talking about some of your earlier point about Shenzhen. So now a lot of big companies move to Sichuan, because of cost of it. So why do you think Shenzhen is better place than other places? Because further away from the government, less control.
So this is secondhand information. So maybe you can tell me if I'm wrong. But my guys like it because there's a kind of a critical mass of innovation there. So it's not just the cost. There are a lot of innovators there who are working together. And there's a lot of startups starting that are doing really interesting things. And so I think that they may work with the other factories in other cities, but there's apparently like a subculture of hardware hackers in Shenzhen, and it's like I think they call it the Shenzai gang, right? And there's a gang of people who, so literally you can go into the market, and this is kind of slightly off the record, but you can buy the schematics for every single mobile phone on the market. And then you can go to the factory and use the same line that they use, and you can buy the same parts that they use on the street, and you can literally kind of hack, an Ericsson device. And again, you would never be able to sell this back in the U.S., and it's really not anything. But if you think about it as a lab rather than as a manufacturing center, it's really interesting because it's like, what if you could take an Ericsson phone and mash it up with a Motorola phone? What would emerge? Well, they're doing that there, and so that's what's I think kind of interesting. It's not the manufacturing part; it's more the hacking part.
It's nothing to do with the Foxconn there, Huawei sitting there.
Yeah. Well, they're the ones that support the ecosystem, right? But I think what's emerged recently is that there's a whole underground innovation center there that people don't really talk about, but I think a lot of people are going and checking out.
Other questions or comments or feedback, reflections?
I'd like to ask, you talk a lot about agility and how to react, and that seems to work better in small environments. So I'd like to know what you experience from going to this kind of very agile and very dynamic environment to something bigger like Media Lab.
Yeah, so that's a good question because I'm doing this on my own team. And it is hard. So Media Lab the whole enterprise is probably 400 or 500 people, so it's not Microsoft, but it's still a big ship. And I am having to create smaller teams that do stuff on the edges, and I'm having to redesign the lab a little bit. And hopefully, once I get the edges sort of sorted out, I'm going to start hacking on the middle. And part of our conversation is about how Microsoft can help me with the new model that I'm trying to introduce. But I do think that the key to it is you do need to create. Here's kind of the way that I've seen large companies successfully do it in certain circumstances, like banks and things. Is you create smaller groups that create either supporting structures or identical structures, and then once you become roughly equivalent in terms of function, you switch over to the new stuff. I don't think you can. It's hard to change existing old stuff, and you can still move the people, but a lot of the structure. What I think you need to do is create a scaffolding and then switch over, rather than to change what exists. And I think one of the key things of change is if it's a new thing, you can build it out as a side thing. If you're trying to change an old thing, what I found traditionally is, because I don't really like changing it and this is not so much the Media Lab, but this is more me talking from the perspective of an investor, is I usually like to get the team to rewrite the whole code in the most modern language, whether that's Ruby on Rails or whatever makes sense, make it test-driven, make it object-oriented, make it agile, and then you separate this big thing out into pieces, and then each component you switch over. But at the beginning, you don't change any of the features. You sort of copy one for one so that you can test compatibility and switch. And once you've switched over to a more agile platform, which is test-driven, object-oriented, and separated into groups, then you can start to modify. You can keep it, but I always like to prevent the messing with legacy in terms of like the forms and the protocol between so I keep business process reengineering and process engineering separate from code engineering. And I like to do the code first and write an equivalent that's cleaner, and then start messing with the people later. Because when you mess with the people and the code together, you don't have a reference. And I think that's one of the biggest problems these big companies do. And then also, and this is kind of maybe negative for Microsoft, I try to get people off of packages. Because packages tend to clump things together and keep them more complex than they have to. I like to try to separate things out. So that's when I'm working on a company or like a startup, I often get everybody to rewrite the code. At Media Lab, it's a slightly different type of organization because it's really more of a community than anything else. I mean, really, literally, I mean, I can't fire the faculty. They're going to do what they want to do anyway. It's really more like running an open source software project than it is like running a company. So I think there are similarities, but there are significant differences, I think, in the Media Lab.
So do I have a quick question for you? Given all that you've been doing and all that you could be doing with a few years of your time, what possessed you to take on this role?
I was surprised as well. Because I wasn't sure when I went to visit the Media Lab what I was getting into. Just Nicholas just told me I had to go. And it was funny because I just read this in Wired the other day, so I didn't know until a couple weeks ago. But they had gone through like 250 candidates. And I was on the list, but they kind of decided that it wouldn't work because I didn't have a degree, right? But then they got through all of them, and they had left was me. And so Nicholas called me up and said, "Come and do an interview." And then I met everybody, and I really fell in love with them, and they fell in love with me. And why I fell in love with them was I met every professor and a bunch of the students over 2 days in like half an hour each, and it was so diverse and so disorganized that I was like, "This is me," right? Because my problem was I was interested in everything. So I was on the board of this and on the board of that and living here and living there because I wanted to do everything. And it was really ripping me apart. But I found that at the Media Lab there was, for every single interest I had, everything from diving to DJing to, UI, whatever, there was somebody who was better at it and focused on it at the Media Lab doing it. And so I was able to, in one place, find something that I could focus on that actually allowed me to take this interest in everything and land it. then I had just turned 45, and I think I was mellowing out a little bit, and I decided that this whole sort of venture investing thing, it was really interesting, but there was a certain, like every single, it was, I don't know how you explain it, but like ventures like this particular kind of like golf club, and it's really perfect for a certain kind of shot, but there are lots of different shots that don't work with that, right? And they all tend to arc in a certain particular way. And when I met the kids at the Media Lab and listened to what they wanted to do, I want to become a social entrepreneur in Africa and work on oral histories, and I wanted it was so much more diverse, and the people were so I'm not saying that venture capitalists aren't interesting to hang out with, but there was an explosion of diversity that I really liked. So to me, and the last thing I'll say is the thing that I've been most successful at in the past, other than sort of investing and stuff like that, was building communities. So it's Creative Commons and the Firefox community, the Fight Against the Evil Empire, all these communities, community management was like a fun thing for me. And when I looked at the Media Lab, it was a community management exercise, and not, and to me that was also an interesting thing. Something that I thought I'd have fun doing.
Great.
Very inspiring talk, thank you. So I recently read this old book, The Lean Startup, and then some of the ideas that they talk about are kind of similar to very fast prototyping and testing and so on. But in that book, they have this validated learning, right? There's some metric. This is a company. This, although you sort of pivot a lot, there's a metric that you can measure the success. But in the Media Lab, it's a kind of academic institution. How would you measure this kind of to see whether you're making progress as you're pivoting?
Yeah, I think that's a really good point. So first of all, I'll say one thing about metrics. So I know Eric really well, and we work together, and it's important to have metrics. And the way that like a good lean startup does is they'll measure millions of things, literally, and they'll really try to find which measurements actually matter, and they'll come up with theories and they'll come up with metrics, but they build the metrics kind of as they go along to try to figure out what are the dials and the drivers for my business to increase virality and adoption and so on. And so it's, which is very different from what big companies and some of my foundation's friends would do, which is they have a theory first, then they create the metrics, and then they deploy the money, which is a metrics-driven planning structure rather than a product that's surrounded by metrics that they use to figure out whether it's successful and to make sure that they capture the learnings. So that's, I would say, even though we use the same word metrics, is very different than we believe in this theory. I'm an economist and I'm right, and hey, wait a second, reality is wrong. My theory doesn't work. So that's one thing. The Media Lab is really, really different because I think in the company you've kind of have a pretty specific trajectory. You've jumped off a cliff, and you're dead. And you're trying to become alive before you hit the bottom. And so you really have a time-limited amount of time to figure out a way to get to sustainable growth. And so you've got to be very focused on the fact that your metrics are growing in a way that people can see. The Media Lab is kind of the before that part. So I mean, a lot of people will say the Media Lab is a bunch of solutions looking for problems. I mean, the kids are really literally just discovering things. And so one example is, the Yo-Yo Ma came and said he wanted a sensor for his bow to sort of understand the movement. So, some of the professors and students put together this sensor. And then Penn and Teller came and said, well, we want on our magic show to be able to twitch and move something over there without the audience knowing. Send a bunch of kids to Las Vegas to set up the Penn and Teller show. And then an NEC engineer comes and says, that's exactly what we need for our airbags to protect the child seats. And then they deployed them in Japanese cars. And so the lab is really more of a sort of a toy box of these solutions, and the companies are the ones that help us think about the constraints and think about the models and where they would go. And so I think we have to have that's why our corporate membership is a really important part of what we do. We do have about a dozen student startups a year, and by the way, we can talk about this later, but I'm setting up a fund for our corporate sponsors to invest side by side with the VCs in all of our student startups. So I do think sometimes the kids will say, hey, I'm going to do this, but it's really hard to do it in the lab. You want to do it outside, because the other part about the lab is that we're really kind of an upstream idea factory. Once you've proven that this idea is showable and demonstratable, you're sort of encouraged to back off of the idea usually. If you really want to turn that into a thing, you usually go off and do directed research, or you go off and join a company that can do it, or you do a startup around it. And I think if we got into commercializing and productizing things too much, we would start running into some conflicts with our sponsors as well, because our sponsor companies are also really diverse. We have manufacturers like, LG, Samsung, Sony, Toshiba. Then we have, software companies, and then we have service companies like British Telecom, and then we have, Hasbro and Hearst, and so it's really, I think it gets complicated if we get too much into the actual business of it.
Why don't we thank Joey? Thanks for